Azure Power Lunch. And as you know, we record this call and place our recordings on our YouTube channel. So if you don't want to be recorded, you may want to drop off now. And Kumar, floor is yours, man.
Good morning, good afternoon. My name is Kumar Raju. I'm a cloud solutions architect here in Microsoft. Today's topic is going to be on the semantic kernel, one of the popular, rather enterprise-ready AI orchestrators in the market today. Uh, just to give me a thumbs up, a thumbs down. How many of you are familiar with semantic kernel? I don't see many, but that's okay. Yeah, that's good. So as AI solutions scale, we all know the complexity grows as well. And in fact, in our lives, we are all familiar with orchestrators like Kubernetes, Azure Kubernetes Service, or OpenShift and whatnot, which manage the complete life cycle of the containers. Similarly, we have these AI orchestrators that allows us to simplify the integration of the AI models, the data that we connect to, and the services, right? Without uh, kind of writing heavy code. Uh, so these are the architectures that was designed or written to simplify the job of developers so that they can plug and play, right? But on top of it, we will these frameworks allows us to, allows the developers to manage the scaling or the standardize the development. But more importantly, as you move towards these to production, you want to focus on security and compliance, right? It's not simply about I have an open source, I'm good to go. So that's where we have this semantic kernel, one of the popular open source frameworks from Microsoft that has been GA. We announced it in the last Ignite, but we continue to add more features in the semantic kernel. So I thought this would be a good time to, kind of talk about semantic kernel. So I wanted to go back to the previous week's conversation where we briefly touched upon agentic AI, and I'll provide some context as to why I'm giving the quick recap for those of you who couldn't join, right? Agentic AI is basically about building systems, right, or processes around large language models, so that we can get accurate knowledge or chat with your data kind of thing, right? So as you know, you can think of these. You can think of using this as a natural language to automate our processes and tasks. That's what this is all about, agentic AI. I mean, since machine learning and AI has been in the market close to 2 to 4 years or 5 years, right? I mean, using natural language processing isn't nothing new. We have been using NLP for years, right, to extract the data and process the data. What's new in the agentic AI is the amount of freedom we can now give to these large language models, right? Which allows them to handle the ambiguity, for that matter, making these decisions dynamically with a minimal human intervention. I mean, as you could see, I like this picture. So we give a prompt, right? As some sort of asking a question, and the tool intelligently determines okay, which tool I should call, where should I route the request to, so that's where it is using the natural language instead of you telling go ahead and call this function. And as soon as it knows which function to call, then it returns the answer. And once it gets an answer, it customizes the natural response and returns it back to the user. So that's where this agentic AI or these AI agents is going to do, right? So the reason I mentioned this agentic AI is because semantic kernel does come under the category of agentic AI. In fact, I would say there has been a lot of momentum, right? It represents a revolutionary approach to artificial intelligence, allowing our systems to autonomously perceive and act on specific goals with minimal human intervention, right? So semantic kernel is one of the frameworks. In fact, it's Microsoft has open sourced it, but it continues to develop, add new features, more integrations, with models, Azure native services, as we discussed in the subsequent slides, that enable the implementation of agentic AI. So I would say this is an extension of the previous week's conversation, but you didn't miss anything. Not to worry. Semantic kernel will continue to add more play as you enhance and expand these agentic AIs, because writing a simple agent is one thing, but as you continue to plug and play plugins to automate your business processes, you need some system to kind of intelligently orchestrate these agents, right? So that's where these frameworks coming into the play. So what is the semantic kernel? Obviously, it's a lightweight open source SDK from Microsoft, and that allows us to build AI agents, right? So the beauty of this is three things that I always wanted to call out. Given the fact it's being fully supported Microsoft, it's going to be what do we call a future proof, right? And easily allowing you to connect your code with the latest models. And this is where we call the model agnostic. What we mean by that is it means the SDK is designed to work with various AI models, right? Today you start with ChatGPT 3, tomorrow 4, or it could be one of the Llama models or anything, right? So it allows you to plug and play. As you see on the right hand side, today you're starting with ChatGPT 3, next year something comes up. So all you have to do is just deploy the new model and specify this in your code. That's all you have to do if you want to take advantage of the new model, right? You have your code. You may be using one of the plugins. That's all. So that's what the beauty of this is. Uh, but what does it give? The model agnostic obviously comes with some features, right? Throughout the presentation, you will see things like compatibility, right? Because semantic kernel obviously integrates with a lot of these OpenAI models, whether it supports OpenAI, Azure OpenAI, or in the future, if you want to use Llama or Hugging Face. Today we suppose Hugging Face, but I'm sure we'll continue to provide support for the open source models too. Uh, and not only that, I'll talk about these plugins too. Developers can create plugins from multiple sources, right? AI services. So that's what I mean by. So today you can use, for example, Azure AI Search or some of the connectors, which allows you to plug and play. And because of that, we call this as a future proof, because as we continue to develop new models, developers can simply plug and play without needing to rewrite the entire their application. So their application is um, seamless, abstracted, but they can continue to leverage these models. So that's where we will continue to call, or there'll be more focus on the modular and extensible stuff, right? So that's what this semantic kernel does. So now there are some of these open source AI frameworks in the market too. So I don't want to call semantic kernel as one of the one. So there was another thing called AutoGen that was also for Microsoft, that was designed for research projects, development purposes. And we will slowly be, if you are following the news from Microsoft blogs, we will be slowly merging AutoGen and semantic kernel to one source, right? But there are some other things like LangChain, Crew AI, AutoGPT, and there are more which I don't know either too. It's hard to catch up. But I'm not familiar with all of these, but I just wanted to put it out there. But we'll be focusing more on semantic kernel. Okay. The thing is, obviously, semantic kernel comes with enterprise ready support. So you could easily, if you are using Azure, you're using Azure AI Foundry, will be using these, developing these agents. Then it comes with a lot of security and compliance, and you can continue to do some lot of telemetry, monitoring, whatnot. You'll be able to completely see all those things when you use semantic kernel in Azure, right? So, at its core, like we all know, anytime we deal with a new product, new feature, there's always a thing called in a kernel, right? It's a central component of the semantic kernel. That's why we call it semantic kernel. But inside it, there is something like a kernel that we always register with it, right? At its simplest, what is it? The kernel is the dependency injection container that manages all of the services and plugins that are necessary to run your agent, right? If you feed, that's what the picture shows. If we feed the models, the connectors, the plugins, the services, then the kernel or the AI orchestrators knows how to handle the request, the models accordingly, right? So all you have to do is modular. You feed it to the kernel, you register with it, and you are good to go. Register with it, or when I say register, you add the service to it in your code, and that's all it requires. Once you register the kernel, add the services, add the plugins, that's it. Boom. You are powering your orchestrator or kernel to do some of these beautiful things, right? So in fact, I would say this is a powerful thing because you are allowing this. Once you do this, you are allowing the kernel to select the best AI service to run your prompt. The prompt could be provided in the natural language, but based on the incoming request which I have showed in the previous slides, you'll be able to select the right connector, right plugin, right service, and then it returns a response in a natural language, right? That's what the kernel does. Now, like any other framework, semantic kernel comes with a lot of connectors, and one of the connectors that we talk about is the AI service connector. So, if you have been playing with, Azure AI Service, there are things like chat completion or text generation, and now there are a lot of those things like text to image and whatnot. So these are some of the things that are available out of the box, and I'm sure we'll continue to add more, right? But essentially, whenever I say, connectors, from your connector code, it some sort of provides an abstraction layer that exposes multiple APIs from different providers via a common interface. That's the beauty of it, right? So you will always be dealing with, you are using a chat completion or text generation. You'll only be dealing with the right API. That's all. But it's a common service. It's like a gateway to take advantage of these AI connectors. Once you specify your need, whether it's a chat completion or text to image, you'll be providing your requirement, and then through these different models, you'll be do that. Similarly, semantic kernel provides these connector options. As you have seen on the right-hand side, today we support many of them, but I'm sure eventually the list continues to grow. But one of the popular things that I have seen working with customers is they use Azure AI search. Once the data is indexed, they can feed this into the semantic kernel. That way, it will index on, it has a knowledge to retrieve the data from your knowledge source versus pulling it from public data. If you recall, we have this RAG model, retrieval augment generation, right? So you can power your kernel and agents to retrieve the data knowledge from your Azure search as well, right? Now, there's also something like a plugins in uh, semantic kernel. So, I mean, as we all know, if you are working on a browser has a lot of plugins. But essentially, plugins are some sort of a named functions or containers. Each this plugin could be your own Python code. It could be a function, or you could be leveraging from open source APIs. Or let's say you have existing business functionality in Logic apps or Azure functions that you'll be able to simply call that instead of rewriting everything from scratch. So that's what the plugins do. You could be writing a brand new plugin, or you could leverage the existing ones, or you could be using Azure Logic apps. However you want it to do, you can just register with the kernel, and then you are good to go. So now, in the last month, we have kind of released this agentic framework because agentic framework continues to build a lot of momentum. So it is some sort of uh, what do you call, a platform within the ecosystem of semantic kernel, right? That allows us to create these AI agents. Now, as of today, we only support Python and .NET, but I'm sure we will continue to add more features to our programming languages. Now, why do I call this a kernel agent? Because essentially it's a framework, makes it easier for us to coordinate, dramatically reduce the code the developers have to write. I mean, I provided a pseudo code here. All you have to do is, just call the right agent that you are interested in. It could be, for example, a chat completion agent or a text to speech or a text to audio and whatnot. It's a few lines of code. And as you noticed here, it's a same common interface that you'll be dealing with. So you have a Python code, and then in your main function, you'll be calling the right agent, or it could be multiple agents that you'll be dealing with. Here I just showed one simple agent and response, but you'll be dealing with some complex agents, complex workflows, right? So today we support these chat completion agent, and OpenAI assistant agents and whatnot. And then we recently released something like Agent Group. So this is an interesting one where you'll be writing multiple agents, all right, and then you want it to coordinate. That's where these agent groups come into play, where all you have to do is you define your agents and then plug it in with agent group, and then it will take care of the coordination and everything. So these are some of these frameworks that you do. All you have to do is um, you know, in your code. So like the way I have showed last week, you're not gonna really, play within the Azure portal, right? So this requires some sort of some learning curve in terms of development, but we have given you the framework, we have given the tools. So as you see, you need to install the semantic kernel, pip install, and then you call the right packages or import the packages that you are interested in. So in this case, for example, I'm interested in a chat completion that I would like to use, right? And then I will be essentially using some of those AI connectors. It could be Azure AI connectors and whatnot, right? Something else in the future, I might be using some third-party connectors. It doesn't need to be an Azure one, so you will be using that. And then what I do is just call some Azure AI services, which I have shown you. Remember, I was telling you the first thing that you do in semantic kernel is you'll kind of initialize the kernel, and then you will continue to add services. When I say add services, AI services, and then add plugins, add and whatnot, and finally you can invoke it. So here is a pseudocode that I'm showing you where you will be registering a service. And then not only that, so let's say you would like to use some telemetry. So you could use one of these logging frameworks in your code, or you could be using Azure Application Insights or Azure Open Source Telemetry, bunch of those, which I will show you, or we may not have time to show that, but you can simply explore that. So those are some of these enterprise services that we are talking about. So we talked about importing the packages and registering the services, adding enterprise services. Now, yes, this is what I wanted to show. So all you are doing is, you are feeding the kernel with all the things that you'll be talking about. So this is an example where you wrote multiple plugins, right? And then you are registering those plugins to the kernel. Right. In this case, I have written multi-agents where I have this report agent, search agent, validation agent, bunch of those. That's where the beauty of it is, right? Just instead of writing a one simple agent, you'll be writing multiple agents. And semantic kernel does the job of an orchestration. And final step is kind of invoking this thing. So if you see the code here, we will be just invoking um, the agent. And once you do that, based on the incoming response, sorry, based on the incoming prompt, we will be able to automatically route the request to either a search agent or a validation agent, depending upon your code. I'm just calling out based on the example that our developers have written. So as you could see, it's all modular in nature. you will not be really writing a new code to take advantage of semantic kernel. All you are doing is just calling the right, importing the right packages, right, registering the with the kernel, and then you are good to go. Of course, you will be still writing your code for your own functionality, whether it's native code that you have to invoke the business service and whatnot. But that's outside of that. The semantic kernel is not designed to uh, reduce the code for the developers to take advantage of this framework, right? So I know we have 10 more minutes. So I just want to quickly show you because I didn't really wanted to write anything, right? So one our developers, you'll always find this in our. Can you guys see my screen? Hopefully you guys can, right? So this is the same framework that I wanted to show you because this is a beautiful example that demonstrates multi-agents, using the multi-agents and how semantic kernel can orchestrate this, right? So the first thing we do is, as I mentioned, import the right packages, right? And then these are the agents that you will have to create or you will be writing. In this case, it could be a native agent that you wrote within your code, but you could also take advantage of, for example, a logic apps or, a function that you already have in Python and whatnot. So this is what you wrote here, search agent that is taking advantage of an Azure AI search, where your data is already indexed, and then you would like to just leverage that, right? But all you are doing is you are feeding the model, right? And then you are passing on some instructions, right? Now the same concept goes. You are creating another agent. It's the same thing. You are just registering the kernel, and then you are feeding the agent the kernel with the model, with the name that you wanted to use and everything, right? Now the same thing, another thing. Now finally, the real piece comes is where, remember, if you guys call, I said uh, kernel is the central component in the semantic kernel. So all you do is first you will register the kernel, and then you continue to add services. In this case, I'm interested in Azure chat completion, right? Because it generates a whole lot of summary for me in terms of my health plan. But then you are doing these plugins, right? The way we talked about, which enhances the functionality of my agent or powers my agent, right? So I'm adding my these report agents, my plugins that I have written above, and then I'm just registering with the kernel. And once I register with the kernel, all I do is I'm just gonna invoke it in the bot, period, right? So if you see this here, yeah, invoke. So once you do this, then you will be able to power the agents based on the incoming prompt. This is a great example of multi-agent system that you can use using a semantic kernel. So so I just wanted to show the same example where you guys could really, we have written this. So I don't want to really rewrite the code and show it to you, smart man, but it's the same concept. So the first thing is, we kind of load these packages, load the environment. In this case, all I'm doing is just calling my model, my Azure AI Foundry, the chat deployment model, what I have written. It's all good, right? So you still need that. So you need some sort of a framework to run your LLMs, to feed the data, to index the data that has been already done. So I run my search agent, which is all good, and then a report agent, which is another plugin that I'm going to use. So this plugin could be a simple Python function that you could use, or it could be an Azure Logic Apps, or it could be an Azure function, or if it's available in the third-party source, then you can just be able to leverage using API calls. But the beauty of this is here, where multi-agent system. All I do is I'm interested to know more about my health plan, about this, the north wind or whatever it is. So when I run this function, it generates a summary of my this thing, right? For example, I'm interested in uh, Northwind Health Plus. Then in this example, uh, we are registering the kernel, we are adding all these services, and then, but most importantly, we are also doing a lot of telemetry, logging. Right. In this case, we are simply using the Python's logging framework, but it could be if you wanted to do as part of instrumentation, you can use Azure Application Insights or some third-party telemetry monitoring solution, whatever it is, you can just do so. Yeah. Then there is something like a prompt templates in semantic kernel, which I haven't had a chance to touch upon it. But as you could see here, we are using these prompt templates to generate some of these user input and data and everything. Okay, so finally, as you could see, I have some logging enabled, which tells me what I am doing, am I searching correctly, reporting, and finally it does the validation where it makes sure that it is generating the right data. So, and then it generated a big one, right? So this is where we are using a chat completion model to power my agent and it generates it. It could be anything. So there are a bunch of examples that in our um, uh, Microsoft's GitHub model that I highly encourage everyone to take a look at it. But essentially, semantic kernel is kind. I just put some references here where you guys can take advantage of go through some learn about semantic kernel agent. Okay, so. Last but not least, it is an open source framework, fully supported by Microsoft, and we continue to add, more features where you can use. In fact, I just wanted to show this. Just last week or a couple of weeks ago, we kind of made this generally available to the public, generally publicly available. So we continue to add more features to our semantic kernel framework. Please uh, check out our GitHub repo where there are a bunch of samples that gives you an insight into what this framework does. Play with it. One of the things that I liked is a chat completion agent using a agent group chat, which I showed you. So please take some time, take a look at it, and play with it, and um, you know, contribute to the community if you guys are interested. So that's pretty much it from my side, Naveed. Handing it over back to you.
Or any questions, folks? Please feel free to open your mic or post question in the chat window. We are right on time. So thank you for your time.
It's kind of a big topic. There's a lot of stuff out there, so it's kind of hard to cover in a half hour. But I just wanted to give you a taste of this agentic AI and how it feeds into how the semantic kernel comes into that category. Based on your favorite programming language, please play with it, whether it's Python or .NET, and then contribute. I'm sure there'll be more applications that we'll be developing and showcasing it to our customers in the future.
No, thank you. Thank you for the, appetizer. Looks really great, and thanks for sharing. A lot to learn. Thank you, folks, and hope to see everybody next week for another session of Azure Power Lunch. And thanks, Kumar, for a very informative session. And hope you bring more sessions like this in the future. Have a great weekend and have a great rest of your day. Thank you. Bye bye.
Thank you all. Have a nice weekend.